October 1944. Luzon's rainy season had turned every road into a river. The Japanese 41st Infantry Division, retreating through the mountains of northern Philippines, halted at the Pampanga River before dawn. From the far bank they could see the jungle mist glowing orange, an American bridgehead forming where the night before there had been nothing but mud and water. Through binoculars, a Japanese engineering officer, Captain Okabe, watched in disbelief. In the span of a single night, U.S. Army engineers had assembled a floating bridge that stretched nearly 200 feet across a current swollen by typhoon rain. The clang of hammers and the deep thud of pontoons echoed through the humid air, mingling with the whistle of artillery overhead. Trucks, jeeps, even Sherman tanks began crawling across as if the river itself had surrendered. Okabe turned to his men, unable to hide his astonishment. His own engineers required 3 days to span a stream half that width, and only under calm conditions. Yet here, under constant fire, the Americans worked by floodlight, their silhouettes steady against the storm. The war, he realized, was no longer about courage alone. It was about velocity, and America had mastered it. By the autumn of 1944, the Pacific War had reached a turning point. The Japanese Empire, once confident of holding a defensive ring from Burma to the Solomons, was collapsing under the weight of American logistics. The Philippines became the next crucial battleground, not only for strategy but for prestige. To Tokyo, holding the islands meant protecting the gateway to Asia. To Washington, it meant cutting Japan's supply arteries once and for all. When General Douglas MacArthur returned to Philippine soil that October, he brought with him the full industrial pulse of the United States, convoys of Liberty ships, columns of armored vehicles, and the vast mechanical confidence of a nation that now produced more steel than the rest of the world combined. Among the most indispensable units following the first assault waves were the combat engineers. Men with wrenches instead of rifles, whose battlefield was mud, tide, and steel. The U.S. Army's engineer battalions had become a phenomenon of their own. In every campaign, from the beaches of Normandy to the jungles of New Guinea, they had turned chaos into order. Their doctrine, refined through thousands of improvisations, was brutally simple. When a bridge was destroyed, build another one immediately. When the front stalled, clear a path. When the army needed to move, no obstacle was allowed to remain a day longer than necessary. In the Philippines, those orders met their hardest test yet. The island's geography was a nightmare of mountains and rivers, its monsoon-fed floods cutting through every valley like trenches dug by nature itself. Japanese defenders, retreating inland after the landings on Leyte and later Luzon, blew up bridges at every crossing. They hoped the terrain would slow the American advance long enough for reinforcements to arrive from Formosa, but what they underestimated was the tempo of U.S. engineering. By 1944, American bridging technology had reached an unmatched level of precision. Prefabricated Bailey bridges, pontoon spans, treadway floats, and portable cranes were mass-produced in the United States, shipped thousands of miles, and assembled by units trained to perform miracles under fire. The 1144th Engineer Combat Group, for example, could construct a 180-foot bridge across a river in less than 12 hours, even while artillery shells exploded around them. To Japanese officers, raised in a military culture that prized endurance and spiritual fortitude over mechanized efficiency, such feats were bewildering. Their own engineers worked with bamboo scaffolds, logs, and rope, heroic in effort but primitive in design. They viewed the American approach as almost mechanical alchemy, soldiers working like machines guided by blueprints and discipline rather than inspiration. As U.S. forces advanced north through Luzon, rivers like the Agno, Pampanga, and Cagayan became symbols of that divide. On one side stood Japanese units clinging to every ridge and ravine. On the other side, convoys of American trucks, bulldozers, and cranes churned through the floodplains, turning raw jungle into road. The thunder of artillery was matched by the steady rhythm of hammers, winches, and acetylene torches. To the Japanese, it seemed impossible that an enemy could keep pace with nature itself. Yet every morning when the fog lifted, new bridges gleamed where none had existed before. Bridges capable of carrying tanks, supply trucks, and ambulances across torrents that the Japanese had believed impassable. The balance of the war was shifting, not only in numbers or weapons but in time itself. America was fighting a war measured in hours, Japan in days. The engineers who achieved these feats rarely appeared in headlines. They slept beside their bulldozers, ate rations from their helmets, and carried rifles coated in mud. But every span they built was a message, to the Japanese, to their own commanders, and to history, that ingenuity had become the most powerful weapon of all. The Pampanga Bridge that Captain Okabe watched through his binoculars that October morning was just one among thousands. Yet in its steel lattice and floating pontoons lay the story of an industrial civilization at war. A story where victory would be measured not in territory, but in the ability to build faster than the world could destroy. By the time the Luzon campaign was underway in early 1945, the rhythm of American engineering had become as predictable as the sunrise. The 13th Engineer Combat Battalion and the 1144th Engineer Group were pushing north behind MacArthur's 6th Army, repairing blown bridges before the smoke had even cleared. Bulldozers dragged away wreckage while reconnaissance planes radioed back span lengths and current speeds. Within hours, prefabricated Bailey sections, treadway pontoons, and floating cranes were moving forward by truck convoys and landing craft. This was not improvisation, it was choreography. Every piece of steel and every rivet had been cataloged, shipped, and scheduled months before the campaign began. American planners in Brisbane and San Francisco had already mapped every major Philippine river crossing using aerial photographs and hydrographic surveys. By the time Japanese engineers set demolition charges, their American counterparts already carried replacement blueprints. It was industrial foresight executed with battlefield urgency. For Japanese commanders, the spectacle was deeply unsettling. In their doctrine, engineers followed infantry, repairing what had been secured. The U.S. Army reversed that logic. Engineers advanced with the assault forces themselves, often crossing rivers under direct enemy fire to establish the very roads along which the battle would unfold. At the Agno River crossing near Bayambang, Japanese artillery units fired continuously through the night, expecting to stall the American advance for days. By dawn, the first Sherman tanks were already rumbling across a completed pontoon bridge. Even veteran officers could not reconcile what they were witnessing. War fought at an industrial tempo beyond imagination. Behind this speed lay the unsung genius of American logistics. The Red Ball-style supply convoys, adapted from Europe, kept materials flowing from depots on Leyte to the front lines on Luzon. Each engineer battalion functioned like a mobile construction company. Welders, surveyors, carpenters, crane operators, and mechanics all working from standardized manuals. When a pontoon burst or a Bailey section buckled, spare parts were already stacked in waterproof crates nearby. Nothing was left to chance. The Japanese, operating from dwindling supplies and fragmented communications, found themselves trapped in a slower age. Their engineers were courageous but overburdened, building bamboo trestles by hand, hauling timber through swamps, and relying on animal transport long after American bulldozers had reshaped the terrain. In their reports, some officers wrote with reluctant admiration, "The Americans seem to create bridges as the gods create land, suddenly and without rest." For American soldiers, the bridges were lifelines. Infantry columns crossing newly built spans cheered as they passed the engineers, tossing ration tins or cigarettes in gratitude. Even battle-hardened troops paused in awe at the sight of a 60-ton tank floating across a river on modular pontoons assembled only hours earlier. Every successful crossing was another psychological blow to the Japanese command structure, a message that resistance could delay, but never halt, the relentless advance. By mid-February 1945, U.S. forces had crossed more than 50 rivers across Luzon alone, many under active fire. The Army Corps of Engineers documented some crossings completed in record time, up to 400 feet of floating bridge erected overnight, while mortar shells fell within yards. Such efficiency forced Japanese divisions to abandon planned defensive lines, retreating faster than their own supply units could follow. For the first time, Japanese officers understood that American power was not measured solely in weapons or numbers, but in the speed at which they could rebuild the world around them. The lessons of Luzon echoed throughout the remainder of the Pacific campaign. On Okinawa, engineers would again construct bridges and airstrips faster than the enemy could destroy them. In Japan's own post-war reconstruction, those same principles, prefabrication, coordination, precision, would become the foundation of a new industrial era. As the Luzon rains continued to fall, Captain Okabe's binoculars remained fixed on the advancing columns. He watched the endless line of vehicles rolling across the glittering span, the reflection of floodlights shimmering in the torrent below. The bridge creaked, swayed, and held firm, an emblem of a nation that had learned to turn steel and time into its ultimate weapons. The story of how American engineers built bridges overnight under enemy fire is more than a feat of construction. It is a portrait of how technology, discipline, and human courage merged into a single rhythm of war. To understand why Japanese officers were astonished, one must explore the many layers behind that speed. The technical mastery, the organization, and the mindset that turned a river into just another obstacle to schedule. The first angle lies in industrial design. The prefabricated Bailey Bridge, invented by British engineer Donald Bailey and refined by the Americans, was one of the quiet revolutions of the war. Its modular trusses, pinned together by a handful of soldiers with nothing but sledgehammers, could bear 30 tons of weight and stretch more than 200 feet across water or rubble. Each component was small enough to be carried by hand, yet when assembled, the structure could support tanks. American engineers memorized the sequence of assembly as though it were a hymn: panel, transom, stringer, decking. When the first pontoon hit the current, a bridge already existed in their minds. The second angle is doctrine. The U.S. Army Corps of Engineers did not simply build. It rehearsed endlessly. Manuals outlined precise standards: how many men per panel, how many minutes per section, and the load calculations for every water velocity. Field schools from Fort Belvoir to the Pacific trained engineers under simulated bombardments. When they reached the Philippines, the muscle memory was so deep that chaos barely slowed them. Japanese observers watching from across the river could not distinguish individual leadership, because there was none in the traditional sense. Every man was a leader of his task, synchronized to an invisible metronome. The third angle is psychological. Under fire, most armies faltered. Engineers, however, thrived on precision amid panic. Their courage was not the loud heroism of bayonet charges, but the quiet defiance of standing upright on an open bridge span while mortars struck the water. They measured success in minutes saved. Every second mattered because every delay meant infantry stalled supplies waiting, or wounded trapped on the far bank. To them, fear was a variable, not an emotion. It was factored into timing charts and accepted as part of the job. Then comes organization. American engineers operated as extensions of a vast supply network that reached back across the Pacific Ocean. Each bridging operation drew from pre-packed units, known as bridge trains. These included trucks loaded in exact sequence: pontoons first, then decking, then tools. Even in pitch darkness, an engineer could reach into the bed of a truck and find the correct bolt by touch alone. That kind of preparation turned the battlefield into a production line. To Japanese planners accustomed to improvisation and shortages, the precision seemed almost supernatural. The fifth angle is adaptability. Not all rivers were equal. Monsoon floods, shifting currents, and debris demanded improvisation. When pontoons broke loose, soldiers dove into the torrent with ropes clenched in their teeth. When enemy shells severed a section, the next span went up alongside it before the firing ceased. Engineers often joked that their bridges never failed. They just relocated downstream. The phrase "grimly humorous" captured their resilience. In war, perfection was impossible, but persistence was invincible. Finally, there is the cultural divide. Japanese officers viewed engineering as a subordinate skill, secondary to the fighting spirit. In contrast, the U.S. Army celebrated the engineer as a frontline warrior of infrastructure. Their motto, "Essayons," let us try, was not bravado, but belief in problem-solving as a form of courage. When rivers rose or roads collapsed, they did not pray for favorable conditions. They built their own. The Japanese could not easily grasp this mentality, forged in the factories of Detroit and the assembly lines of Pittsburgh, where progress was measured in units per hour. The same spirit that had built skyscrapers and highways now spanned rivers under artillery fire. At dawn, as the fog thinned and another steel span locked into place, the Japanese across the river felt a mixture of awe and dread. They were watching a new form of warfare unfold, not a contest of endurance but of efficiency. And in that contest, America's engineers were undefeated. The clang of metal on metal, the shout of panel up, and the deep thud of boots on planks became the soundtrack of an empire's retreat. Every bridge was not only a path forward, but a symbol that no destruction could last longer than a single night. Beyond technique and courage, there was something deeper that stunned Japanese officers watching those bridges rise: the American relationship between technology and faith. In Japanese military culture, faith was spiritual, rooted in tradition, loyalty, and the emperor's divine cause. In the American version, faith was practical, the belief that with enough material, method, and manpower, any obstacle could be solved. Where one side prayed to endure, the other simply planned to overcome. At the heart of that difference stood the U.S. Army Engineer Battalions, ordinary men guided by extraordinary systems. Their efficiency did not depend on heroism alone, but on standardization, the quiet revolution that made miracles repeatable. Every nut, beam, and float was identical to thousands of others. This meant a soldier who had built a bridge in Italy could do the same in the Philippines without a single adjustment. It was as if America had built not just bridges, but an entire method for overcoming chaos, a process that could be taught, scaled, and exported. Japanese observers took notes feverishly, trying to decipher the pattern. They could see the steel, the trucks, the cranes, but not the invisible structure that held them together: logistical intelligence. The Americans fought with mathematics and scheduling charts as much as with rifles. A U.S. sergeant armed with a slide rule could reroute a column of tanks as efficiently as a general commanding a division. The Japanese, still relying on verbal orders and intuition, realized too late that they were fighting a culture where organization itself was a weapon. Then came the human dimension. The engineers were not faceless technicians. They were the sons of carpenters, machinists, and railroad workers, men who had grown up fixing machines before learning to fire guns. They approached bridges the way an artist approaches a canvas, with a mixture of pride and obsession. Letters home described rivers as adversaries to outthink, not enemies to hate. "We build so others can fight," one corporal wrote, "and that's enough." Their sense of mission gave them a quiet confidence that even enemy officers could sense. They didn't look hurried, just inevitable. Another angle was inter-service coordination. In the Philippines, engineers often worked side by side with Navy Seabees, blending military precision with civilian inventiveness. Where the Army brought structure, the Seabees brought improvisation. When pontoon boats ran short, they lashed empty fuel drums together. When cranes bogged down in mud, they built wooden ramps on the spot. To the Japanese, it looked like chaos, yet every adjustment fit within a flexible plan. That fusion of discipline and creativity was uniquely American, born of a nation that valued individual initiative within collective goals. Even the environment itself became an ally. The U.S. military had studied Pacific hydrology months in advance. Meteorological teams predicted tides and floods. Engineers carried charts showing soil types and bridge load coefficients. While the Japanese tried to use nature as a weapon, flooding valleys and destroying culverts, the Americans treated nature as data. They built bridges that floated higher during storms and disassembled when rivers changed course. In a war fought on islands and archipelagos, that understanding of geography as an engineering problem was revolutionary. But perhaps the most overlooked angle was morale. For infantrymen slogging through mud, the sight of a completed bridge was more than logistical progress. It was psychological relief. It meant that no river, no matter how swollen or mined, could halt their advance. Soldiers crossing those spans often saluted the engineers as they passed. The bridge became a symbol of homegrown American resilience, simple, strong, and endlessly repeatable. On the other side, Japanese morale crumbled. Officers who had ordered demolitions in the night awoke to see replacement bridges by dawn. The cycle of destruction and rebuilding eroded faith in their own defensive strategy. Reports intercepted by U.S. intelligence revealed a tone of despair. "They build as fast as we destroy. Their strength is time." That realization, that war was now fought in hours instead of months, was more terrifying than any weapon. When the last American convoys rolled over the Pampanga Bridge that spring, even the Japanese engineers who had studied Western designs before, the war stood in silence. They understood that this was not just a battle for territory. It was the birth of a new, industrial age where knowledge, precision, and manpower had replaced brute endurance. What began as disbelief evolved into reluctant admiration. Many Japanese officers later cited those bridges in post-war studies as proof that America's greatest weapon was not the atomic bomb, but its ability to organize the chaos of modern war into a system that always moved forward. The rivers of Luzon had been conquered not by force but by design. By March 1945, the war in the Philippines had become a race against rain and ruin. American divisions were driving north toward Baguio and Manila, and every river between them had been turned into a fortress by retreating Japanese troops. Demolished bridges, cratered approaches, and mined fords littered the landscape. What the Japanese High Command expected to stall the U.S. advance for a week was being erased in a matter of hours, and the defining proof came at the Agno River. At dusk on March 8, 1945, elements of the 37th Infantry Division reached the south bank. The 14th Japanese Area Army had blown every crossing, and artillery from the opposite ridge raked the shoreline. Yet instead of waiting for darkness or reinforcement, the 1171st Engineer Group rolled forward its bridge trains. Floodlights flared through the drizzle as bulldozers shoved debris aside and half-tracks reversed down the embankment, carrying pontoons. Japanese officers peering through rangefinders could scarcely believe the sight. The Americans were building in plain view. For hours, a duel unfolded between destruction and construction. Each salvo of shells tore away fresh timber. Each blast was answered by a dozen hammers striking steel pins back into place. Lieutenant Colonel James W. Hubbard walked the length of the half-finished treadway, shouting time marks. 30 minutes to tank weight. His men kept rhythm to the thunder of artillery, laying one 25-foot section every 6 minutes. By midnight, despite losing 27 men, the first jeep rolled across to cheers from the far bank. The Japanese batteries fell silent, not for lack of ammunition, but for disbelief. Reports later recovered from their headquarters described the crossing as impossible to comprehend. The bridge grew like bamboo after rain. The phrase became a symbol within the U.S. Corps of Engineers. Some scrawled it on the bridge's end post before moving on. When daylight broke, the full scope of the operation emerged. Over 400 feet of floating treadway now spanned the Agno, secured by cables thicker than a man's wrist. American tanks streamed over while supply trucks queued in perfect order, air cover from P-38. Lightning circled above to suppress any remaining enemy fire. It was not only a tactical success, it was a psychological reversal. The Japanese had weaponized destruction. The Americans had turned reconstruction into a weapon far deadlier. Further south at the Pampanga River, another bridge was already taking shape. General Walter Kruger's 6th Army could now coordinate simultaneous crossings 50 miles apart. Radio messages crackled with efficiency codes. Bridge able complete 0500 hours. Traffic flowing. The speed astonished Allied observers. British officers visiting from Burma recorded that American engineers had reduced a 3-day operation to less than 12 hours. Japanese captives interrogated afterward spoke of demoralization spreading through their ranks. "We destroyed everything," one sergeant admitted, "but the Americans rebuilt faster than we could retreat." Another officer wrote in his diary that night, "Our engineers study destruction. Theirs study rebirth." That sentence captured the turning point of the Pacific War. For the first time, Japanese command realized that American mobility was not dependent on existing infrastructure. They created it wherever needed. The enemy could scorch the land but not stop the advance. At high noon, correspondents embedded with the 25th Infantry Division described the spectacle as the sound of victory made of rivets and rope. Soldiers crossing the bridge waved at engineers still ankle-deep in water, some too exhausted to lift their heads. The bridge shook under the weight of Sherman tanks, but it held, testament to a geometry perfected by repetition and paid for in sweat. When General Douglas MacArthur received the field report, he underlined one phrase in red: "Bridge completed under direct fire." To him, that single sentence summarized the new American art of war: speed married to courage, technology fused with tenacity. Within 48 hours, armored columns had reached the next line of rivers. The once formidable defensive network across central Luzon had collapsed like wet paper. From that moment, the war's tempo changed irreversibly. The Japanese army could still fight bravely, but it could no longer slow the inevitable. Every river crossed was a calendar page torn away. Every bridge left standing behind the retreating troops was a reminder that time itself had chosen a side. As night fell again over the Philippine valleys, the glow of acetylene torches reflected off the black water. Sparks drifted upward like fireflies. On the far bank, American infantry dug in while engineers cleaned mud from their hands and marked another miracle complete. The next mission order was already in motion. Proceed to Agno East, construct secondary bridge by 0400. The rhythm never stopped. Bridges rose as fast as trees could fall, each one a triumph of planning over panic. In that relentless cadence, the Japanese officers found no weakness to exploit, only a realization. They were fighting an enemy who could build the future faster than they could defend the past. The Agno crossing had been the moment that broke the spell of impossible. But it was the campaign's next challenge, the Abra and Pampanga rivers, that transformed that miracle into a system. The Japanese now understood what was coming. They mined every ford, wired the banks with explosives, and sighted machine guns on every likely approach. What they did not grasp was that American bridging doctrine had evolved into a combat maneuver in its own right. To destroy a bridge meant little if the enemy could replace it before the smoke cleared. On March 18, 1945, rain hammered the plains once more. The 2nd Engineer Special Brigade moved in convoy, headlights blacked out, bulldozers leading. The Japanese opened fire the moment the first pontoon touched water, tracer rounds cutting streaks through the rain. Yet the engineers kept advancing, knee-deep in current, unspooling steel cables as though threading a loom. A single misstep meant death, but the discipline held. Behind them, floodlight generators coughed to life, draping the entire scene in ghostly white. A defiant act that said plainly, "We will build in full view of the enemy." Observers from the 32nd Infantry Division later called it the night the Americans built daylight. The Japanese gunners emptied their magazines, but each flash of muzzle fire only illuminated another panel locking into place. When the bridge reached midstream, mortar teams on the near bank fired smoke shells in a tight rhythm, obscuring the final anchoring. At 2 a.m., the first M4A3 Sherman crept across, its treads clanging on steel decking still slick with rain. By dawn, convoys were rolling over a 500-foot span that had not existed 12 hours earlier. For the Japanese officers watching from the high ridges, it was no longer an engineering puzzle. It was a revelation of American intent. Their own sappers built to survive. The Americans built to advance. The distinction was decisive. Japanese demolition teams sent downstream by boat were swept away by current or caught in crossfire. By the time dawn broke, U.S. trucks were already hauling fuel drums, rations, and wounded across. The bridge was more than a structure. It was momentum made visible. Radio Tokyo that week issued a terse bulletin admitting enemy bridge constructed under fire. But it was the next sentence that captured the shift in tone. They possess a spirit of construction we cannot match. The phrase was quietly censored in later editions, but by then the truth had traveled through the ranks. Even Japanese engineers who had studied German bridging manuals before the war recognized that their methods belonged to another century. The tactical implications were immense. Where Japanese strategy relied on terrain, mountains, jungles, rivers, to slow mechanized assault, the Americans erased terrain altogether. Rivers became highways, swamps became runways, and beaches became ports. The engineers were not a support arm anymore. They were the artery of invasion. Their bridges carried not just tanks but the rhythm of an industrial nation, whose entire economy had been repurposed for velocity. Technically, the achievement was staggering. The pontoon bridge at Pampanga was calculated to bear 65 tons per span. Each modular float was filled, lashed, and locked in under 15 minutes. Crews rotated every 2 hours to prevent collapse from exhaustion. Field telephones ran along the bridge to coordinate load spacing, and when the river rose 18 inches overnight, ballast was redistributed before sunrise. These refinements were invisible to the enemy, but lethal in their effect. The bridge never faltered even under the heaviest traffic. When General Kruger walked the length of that span the following morning, reporters noted that he paused midway, listening to the hum of engines above the river. "This," he said softly, "is what wins wars." Behind him, the engineers were already packing up unused panels for the next crossing. They had turned combat construction into choreography. In the Japanese field diaries found later, the shock is almost poetic. One captain wrote, "Last night the Americans built a bridge as if weaving silk. We fired until the barrels glowed, but the bridge grew longer. Another described the sound of hammering echoing across the water as the heartbeat of an empire. For soldiers who had been taught that courage and sacrifice were the highest virtues, the discovery that efficiency could be equally divine was deeply unsettling. By late March, the fall of Luzon was no longer in doubt. The U.S. Sixth Army had crossed every major river in central Philippines. Their momentum rolled on toward Baguio, where MacArthur would soon declare the liberation of the islands. Yet the engineers received no parades, only a new order: prepare for Okinawa. There, amid coral reefs and artillery fire, they would build again: bridges, docks, causeways, each one another lesson in what the enemy once called impossible. In hindsight, historians regard those Philippine crossings as the prototype for modern combat engineering. They marked the moment when logistics became strategy and speed became a form of firepower. To the men who built them, it was simply another night's work. To the enemy watching from the far bank, it was the moment the war's outcome became visible in steel and smoke. As the last trucks rumbled across and the bridge creaked under their weight, the river beneath carried away broken timbers from the Japanese demolitions, relics of a fading doctrine. Above them, the new bridge gleamed under the tropical sun, solid and quiet. It did not roar like artillery or flash like bombs, yet it spoke more clearly than either. America's will to build was unstoppable. When the campaign closed, the engineers dismantled most of those treadways as quietly as they had built them. The war diary of the 1171st recorded only numbers: bridges built, 27; destroyed, 0. Yet in those statistics lay the story of a doctrine that would reshape modern warfare. U.S. Field. Reports noted that average bridge construction time in combat zones had fallen from 48 hours in 1943 to under 12 by 1945. What seemed a logistical curiosity had become the decisive enabler of blitz warfare across oceans. For Japanese survivors, captured along the river lines, the shock endured. Many spoke afterward of the steel rivers the Americans carried with them. When Allied occupation forces later rebuilt Japanese infrastructure, some of those same officers worked beside American engineers, studying Bailey Bridge blueprints and modular decking they once tried to destroy. Reconstruction in Asia, and decades later Japan's own highway system, drew directly from those lessons of adaptability and mass production learned in defeat. History remembers generals, yet sometimes the truest victories are measured in rivets rather than medals. The engineers who built bridges under fire in the Philippines proved that intelligence and organization could be as lethal as any weapon. Each floating span was a quiet proclamation of modernity, that an industrial democracy could convert factories and farmhands into a machine capable of erasing distance itself. For the men who witnessed it from the far shore, it was more than a tactical loss, it was the end of an age. The vision of Americans building through bombardment showed that wars of attrition were over. Wars of momentum had begun. In every bridgehead that followed, from Okinawa to the Rhine, the same rhythm echoed: measurement, teamwork, persistence. When peace finally returned, those who survived carried home not tales of destruction but of creation amid chaos. They had learned that progress, once unleashed, is harder to stop than any army. Across the Pacific, where rivers once divided enemies, new bridges now connected nations that had once fired across the same water. The span between war and peace, between ruin and rebuilding, was built the same way the engineers had done it, one section at a time, under pressure, until the impossible held firm.